Hi everyone, for my tutorial I'm going to be talking about figure 13.23, Hebbian synapses. So let's just get started with some definitions so we're all on the same page before I get into what a Hebbian synapse actually is. So the first definition is a synapse, which is the gap that allows neurons to send signals to one another between two neurons. And then we have a neuroplasticity, which is the brain's ability to change and form new connections in response to changes in the environment. And this is absolutely essential for this chapter, which is on learning and memory. This is at the basis of how we learn and how we form new memories. And then lastly is tetanus, which is the word for high-frequency stimuli. And this is very important for Hebbian synapses. So, next we have long-term potentiation, which is pretty much the same thing as Hebbian synapses, but this is more of a concrete, scientifically experimented idea, whereas Hebbian synapses are a theoretical concept based on a theory by Donald Hebb, which I'll talk about in the next slide. But anyways, long-term potentiation is the increase in the effectiveness of a synapse as a result of repeated strong stimulation. So basically, a synapse is going to be more effective when there's a strong stimulation, like a tetanus, as I talked about in the last slide. Yes, and then Donald Hebb's theory is basically the same thing. More specifically, he proposes that when a presynaptic and a postsynaptic neuron are repeatedly activated, the connection becomes stronger. So when a tetanus is fired in the presynaptic neurons, the response of the postsynaptic neurons is to also fire repeatedly, which creates long-term potentiation. And then the neural connections are strengthened for a long period of time. And, yep. So here's the figure. Something really important with Hebbian synapses is as they strengthen, the transmission of the signals becomes more efficient, as you can see. And eventually the strengthened inputs form new connections, and the weakened synapses fade away. So Hebbian synapses are very strong, as you can see on the top. The cells fire synchronously, and they therefore strengthen the synapses. And then on the bottom half, the cells that fire at random, not synchronously, will become ineffective and eventually fade away because they're too weak. To help us understand this concept in a more fun way, I have a little analogy. So here in this picture, we have Luke on the left and Elise on the right, and they're learning a dance. So Elise represents the presynaptic neuron, and she is taking the lead on showing Luke the dance, who is the postsynaptic neuron. She takes the lead, and she shows Luke the steps and the movements they need to perform. And as they go through the routine, Elise's instructions over time become more synchronized with Luke's movements. This represents the strengthening of the connection between the presynaptic and the postsynaptic neurons. Now, there are particular sections of the routine that are difficult, and Luke struggles to keep up with Elise's instructions. But as they continue to repeat and repeat and repeat, Luke starts to anticipate Elise's cues better, and he's able to adjust his movements accordingly, and therefore become more efficient. Elise's instructions are the presynaptic signals, and Luke's responses and adjustments represent the postsynaptic responses. And the more that they practice and practice, they become more coordinated, and this reflects the strengthening of the synapse between the presynaptic and the postsynaptic neuron due to the high frequency, which is the high frequency of practicing, and synchronized activity. So the more and more that they practice, which is the so-called stimuli, high-frequency stimuli, the more that their coordination becomes strengthened. Just a silly little example, but I hope that helps helps you understand how Hebbian synapses work.